So we're going to do negative 7 minus 1. Once again, negative 7, I'm at negative. I go one step further in the negative direction. I should be at negative 8. S to the 5th. Now, some of us left it as that, but you're going to note that it says we can only have positive exponents. Yeah, Kim. We have to put a 1 over the r to the 8th, yes. So we need to rewrite that r to the negative as 1 over r to the 8th times s to the 5th. You could leave it as that if you wanted to, but usually we throw this on top to give us s to the 5th over r to the 8th. Well, tell that's why I talked about you had that 1 over r to the 8th, and also you turned it back to just r to the 8th. Like you made it positive, and you said, nah, I'm going to get rid of the fraction because I'm sick of it. We got to use that fraction, right? Are we good on all those? So let's just, real quick, let's talk about our timeline here, okay? On Monday, I was showing some people we're going to get a pink sheet that has all these rules on it. That's what we're going to do on Monday. We're going to fill out everything we've learned. That includes, remember, distributing, where we had the parentheses, we had that quiz on it. Factoring, all that stuff's going to be on it. We're going to have one pink sheet that has everything on it. So that's Monday. Tuesday, we'll have powers to powers. That's going to be weird. It's going to be like x squared to the 3rd. Thursday is going to be practice all of our rules.
We don't have to on Thursday.
I'm sorry, Friday. Thank you. That following Tuesday is a review day, or Wednesday is a review day, and that following Friday is going to be our test. So not next Friday, but the Friday after. So 2 weeks from today is our test on this stuff. And you can see that all on your layout where you're checking your answers, okay? We clear on that? Okay, yeah.
Are we going to study for the end of the year test with like all the stuff?
We will have time to do that. But here's the good thing about this class. Have you noticed every single review we have has old material on it? This class, I just kind of keep churning that material out at you. So the review for this one's going to have stuff to review on. So I promise you, if you've been sticking with us, the review for the final is going to be pretty easy because you're like, I've studied this for every single test. Like, our final is going to be basically just a normal test to us. I hope. That's the goal of it, that we just keep churning this information out and that we can do well on that final exam, or our midterm. Make sense? Okay. Hey, we got a new lesson today, but before we get to a new lesson, I always like, do we have homework questions? Because I do have all the homework up here, and I would love to get some questions. Yeah. On 26, let's take a peek at it. Because 26 is... Those have to be the most difficult ones, right? Those are absolutely the most difficult ones. Now, if you need me to rewrite stuff, awesome. I'm just going to highlight what I'm kind of doing in my head, okay? So I'm going to highlight the fact that, see this negative 4 here? There's really a 1 here, right? It's 1 mn, but 1 times negative 4 doesn't do anything. So I'm not going to circle anything. But then we have this negative 2, right? We can multiply numbers, correct? Yeah. So now we just have to take our time and make sure we do this correctly, because what happens if I have a negative times a negative? Positive. It becomes a positive. And what's 4 times 2? 8, the old ocho. So we're going to have a big old 8 out in front. Now remember, when you multiply, you don't need like terms. Well, kind of. You need to have the same bases. So I'm going to notice this m. This m right here appears 3 times. So I know I'm going to need a base m, right? Mm-hmm. And now what we do, everything's changed by multiplication, right? There's no adding or subtracting. So everything's being multiplied. So if we're multiplying, we're going to steal this 5. So we have m to the 5th. Then we're going to steal the power here. What power is hidden right here? 1. So I'm going to steal that 1. So it'll be 5 plus 1. Plus, Malia, since you asked this,
there's another m too.
What's my next number? So I have 5 plus 1 plus 2. Perfect. Make sense? Okay, now we'll switch to our n, because we're done with the m's, right? So we have 3 n's again. So we're going to multiply that by n to the... Does 7 make sense?
Yeah.
Okay, and then we have a... 1, and then we have a 6. So it's 7 plus 1 plus 6. So our final answer is going to be 8 m to the 5 plus 1 is 6, plus 2 is going to be m to the 8th. N to the 7 plus 1 is 8, plus 6 is going to be 14. Yeah. And that's actually our final answer. It's all about grouping those things together. Taking what looks complicated and simplifying it as best we can by just taking those individual elements and going, oh, I can do m to the 5th times m squared. So if you can do that, you can do the big problem as well. Campbell.
How do you do number 23? Like, I know
Okay.
I don't know if you change the negative, make it.
Let's do it. Let's do it. Let's do it together. All right, so I'm going to notice that, you see that negative 4 and negative 3, that's being multiplied, right? Negative times a negative is a positive. You already told me it's positive 12. Then we have v to the 3rd plus, now we have that negative 10, right? So we have 3 plus a negative 10. Well, 12, I'm confident I can rewrite that. And we got v to the, so I'm at 3, right? 3 from the 0, and I need to take 10 steps in the negative direction, which should give us negative 7. Thank you.
Couldn't you change it to a positive exponent?
We are going to change it to a positive exponent by throwing it to the bottom. Because v to the negative 7th is really 1 over v to the 7th, right? So I'm just going to simply throw that to the bottom and write this as 12 over v to the 7th.
Why did we get rid of the 3?
We didn't. We didn't get rid of any. We added this 3. And we did the negative 4 times the negative 3 to give me my positive 12. So we used both 3's. I used this 3 when I multiplied by the 4. And I used this 3 to add to the negative 10. Is that clear? I wasn't sure what 3 you're talking about, but did I cover that question? Yeah.
I have one more.
Yeah, let's do it.
Number 25.
Number 25. Okay, cool. All right, so we're going to have a little bit trickier time with this because I do have to do this multiplication here. Now remember, when we do this multiplication, when you multiply fractions, you multiply straight across. So you need to start, instead of picturing it as negative 18, I picture it as negative 18 over 1. Because then we'll have the 2 times the negative 18, and we'll have the 3 times 1. Okay? So 2 times the negative 18 is actually going to be a negative 36 divided by 3. And you're going to see you're going to be able to simplify that. So I could have plugged that in my calculator. That should come out to a negative 12. But I'd like to see this step that we're thinking through multiplying fractions. Okay, then we're going to have a to the negative 2 plus, see that negative 3? I have that negative 2 plus that negative 3. And then we'll do b to the negative 1 plus 1. Negative 1 plus 1? Good with that? Okay. And I said negative 36 divided by 3. I'm just telling you right now is negative 12. You could plug in your calculator and double check me on that. But it is negative 12. Then we're going to have a to the negative 5. And then we're going to have b to the 0th. Because I have negative 1 plus 1. If I'm standing at negative 1 and I take one step towards 0, I'm at 0. Good with that? Hey, does anyone remember what happens if I have anything to the 0th power? It just turns into a 1. So instead of b to the 0th, that should be just 1. So I'm kind of done with it. If it's 1, it doesn't change anything. And then I'm going to throw the a to the bottom, so I have a positive 5. So we're going to have a negative 12 over a to the 5th. Sorry, I kind of ran out of room here because I was trying to do all of my steps. But does that all make sense?
Yes.
Okay. Number 27. Number 27. Hey, guys, pay attention to this. Is this whole thing, now, before you just start, yes, make sure you pay attention. Is this whole thing multiplication? No. Do you see that addition between it? It turns it into 2 problems. You need to, remember, PEMDAS says we have to do parentheses first, exponents, multiplication, and then addition. So I need to simplify all of the sides first before I do that addition. So we're going to notice we have this multiplication right here, right? I need to take care of that multiplication first before I deal with the addition. Does that make sense? We tracking? All right. So if we notice here, we have two a's being multiplied. That is a to the first plus that 6. Because I did have that a to the first, I got this 6 right here. We have b to the first and b to the fourth. So we're going to have b to the 1 plus 4. And finally, we're going to have, it looks like c cubed is just by itself. And we do still have that plus 9a 7b fifth c cubed. Ty, you asked this question, right? Does all that make sense so far? Okay, now let's simplify this. This will turn to a to the 7th, b to the 5th, c cubed. The other one is 9a to the 7th, b to the 5th, c cubed. Do we notice any similarities between the two things on the opposite sides of the addition sign? They're like terms, right? So I have one of these plus another 9 of these. How many do I have of them?
You have
If I have one of them and I add 9 more of them, how many do I have of them?
18. Wait, 9 plus 9?
If I have one of
2.
them, can we stop shouting out answers, please? If I have one of them and I add 9 of them to it, how many do I have? I have 10. 1 plus 9 is 10. If I have one of these plus 9 of them, it would give me 10 a to the 7th, b to the 5, c cubed. Ty, does that all make sense? Okay. Good? Okay. So, quick rehash. When we multiply things with exponents, we add them, right? So if I have x squared times x to the 5th, we do 5 plus 2, and I end up with x to the 7th. When you add stuff, let's go back to here. When I add stuff, do the powers change? No, the number in front of it changes. So when I add things with exponents, the powers don't change. When I multiply them, we add them. When we divide them, Gabby, do you mind picking up your head? When we divide them, we're actually going to subtract. So if I have x to the a over x to the b, we're going to rewrite that as x to the a minus b. So when I multiply, I add. When I divide, I subtract.
So,
Yeah.
I would say for number 1, would it be like 1 over 2? Like 1 squared? What?
There'll be something with squared. I think we're on the right path. We just kind of got rid of our base. So let's use this idea. So this is going to remain x to the a minus b, right? What's our base on the top and bottom?
12. But then if you divide that and 12 divided by 12, it's more.
No, we don't. We're just dealing with powers. We just deal with the powers first. We don't do the 12 divided by 12. Remember, exponents come first, right? Exponents always come first before we do our division. So we have to see how the division affects the exponents. So you had the right idea, except our base is going to remain 12. But now we're going to take that top exponent, which is 7, and subtract the bottom one, which is the 2. Because it's kind of like multiplication, except we throw a subtraction sign in there. So our end answer is going to be 12. 7 minus 2 is 5. So we'll have 2 to the 5th. And I'm going to stop there, because I know you guys can plug this in your calculator if you wanted to. So this is more important than us plugging stuff in our calculator. If you want to, you can put the answer really small here, but this is our most important thing.
It's not 7 minus 2, 7 minus 5.
Oh, it's 7 minus 5. Thank you. Thank you. I think I knew the answer.
I'm going to write it over for a quiz.
Oh, yeah. We'll do that as soon as we're done, okay?
Mr. Pabian,
Just remind me, okay?
What am I grade?
So it should have been 12 squared. I'm sorry, I wrote the wrong number, because it should have been the 7 and the 5. I was looking at the answer being squared, so we should have 7 minus 5.
if you don't put the answer in, we get the question wrong.
Like the full answer? Because the full answer should be 144. So if you want to, you can put those in. Maybe I'll give you extra credit if you finish it like that. But my most important thing is that we can do 12 squared, okay? Because something's going to be really, really big. I don't want us to have to write out like 6,855,000, something like that. All right, for our next one, what's our base? Negative 6. Is it the same on the top and bottom? Yes. They must be the same on top and bottom to deal with those exponents. Okay, they're the same on the top and bottom. So we're going to make sure we do a negative 6. And we're going to do, is it 12 plus 4? Minus, because we're dividing, right? So I have 12 minus 4. So we're going to have a negative 6 raised to the 12 minus 4, which is 8. It can be, but it's a lot of rules, right? We have a lot of rules. We have when we're adding them, we don't change the powers. We multiply, we add them. When we divide them, we subtract them. So it's just kind of confusing the rules that can really get us messed up. Yeah.
Will there ever be a problem where it has division and addition?
Yes. Yep. And we'll have those in this homework. Okay, our next one. Do we have the same base on top and bottom?
Yes.
Okay, which is going to be 4, right? And we should have 4 to the 10.
14.
What was that?
Wouldn't it just be 14?
Well, we have to subtract. What power is technically here?
1.
There's technically a 1 there. So it'd be 10 minus 1, which is 9, which is 4 to the 9th. If you could finish those last 3, if you want to continue on, awesome. I'm just going to wait till I can see that the rest of us can get the next 3. So we're doing 4, 5, and 6. Yep. We're just running a little short on time. So you should have realized that this one is 9 to the negative 3. You sure? It should be negative 2. Thank you. And it's not our final answer because I need to turn it into a fraction, so we'll put it as 1 over 9 squared. 8 to the 6th, 8 to the 6th. This is kind of a weird one, too. I kind of let you on the weird ones because that'd be 8 to the 6 minus 6, which equals 8 to the 0th. Yeah. Oh, sorry. It would not be 8 to the power of 1. Because 6 minus 6 is 0. What's anything to the 0th power? 1. This is an easy way to lose a point because the answer is not 8 to the 0th. Your answer is actually 1 to have that one correct. So you need to have a 1 there to have that one correct. Our next one, we should have, negative 5 to the negative 1 minus 2. Well, if I'm at negative 1, I'm going further in the negative direction. You should have had negative 5 to the negative 3, right? So negative 5 to the negative 3. We need to make that positive, so your end answer should have been 1 over negative 5 to the 3rd. We keep the negative, though. That's not a negative exponent. We can have negative numbers. You just can't have negative exponents. Questions? We good? Okay, we're going to keep pushing because I want to get through as much of this as we can. Let's look at number 7. Number 7, I have x to the 10th over x squared. Well, this is the same thing as if I had numbers on it. We're going to have x to the 10th. Is it plus or minus if we're dividing? Okay, no answer, so I guess it's plus 2. Minus 2? Okay. And then we just have x to the 8th. Let's go down. Let's do number 10. Let's do number 10 together. Now remember, you can only divide like bases. See how we have the m's and the n's? We have like bases. So my answer better have an m and an n in it. What am I putting the power of m to? 3? 3 minus 2. That's why we do all the steps, so we don't accidentally just yell out 5, because it's 3 minus 2, which is definitely not 5. And we do n to the 6 minus 2. So we're going to have m to the 3 minus 2, which is m to the 1st. We can just put m if we want to. I like putting first because I saw what happened, but you can just put m. And then we have times n to the 6 minus 2, which is n to the 4th. I'm going to do number 11 with you. Yeah. Okay, number 11. we should have r to the 2 minus a negative 3. Now, hold on. That's correct. Because we do subtract whatever's here, right? So I have r to the 2 minus negative 3. It becomes positive. Yes, but we'll get to that in a second. Then we'll have s to the negative 5 minus 2. Remember, we are subtracting, so we always have to add a new subtraction sign to everything. Kayla, you mind picking up your head? I know you're working, but a lot of studies show that you do better if you just keep our head up. All right. What happens when I subtract a negative? We make an adding. So I'm going to go ahead and I'm going to circle the minus minus, and I'll turn it into an addition. So we're now going to have r to the 5th. S to the negative 7th, because negative 5 minus 2 is further negative, which we need to rewrite as r to the 5th stays on top. The s to the 7th goes to the bottom because a negative sends you to the bottom. I would like you to do the 3 that we did not do. So we're doing 8, 9, and 12, okay? Did w squared over w to the 7th. We should have realized it's w squared minus 7, right? Which should have been w to the negative 5. Positive 5.
Oh, I think that is.
We will get to, it's got to be a positive 5, right? Because 2 minus 7 is negative 5, but we can't have negatives in the exponent. We're going to make it a fraction. To the 5th. Yep, you got it. As long as you know our rules, this stuff isn't so bad. Our next one looks like it's going to be negative as well, right? Because we're going to have p to the... Oh, crap, there's no power here. What do I do if there's no power there? It's to the 1st. So we should have 1 minus 4, which should be p to the negative 3. Once again, if I have a negative exponent, we just put 1 over p cubed. So this one should be 1 over p cubed. All right, I'm going to cheat the next one a little bit. I'm not going to show every single step. I'm going to say, well, we could do this in our head or in our calculator, right? What's 2 minus 9? It is negative 7. What's 9 minus 3? 6. And what's 4 minus 4?
1. It's 1.
It's 0. 4 minus 4 is 0.
Oh, minus 4. Okay.
Because 4 minus 4 has to be 0, because what's 4 minus 3? 1. And 4 minus 4 is different than 4 minus 3, right? What happens if we have anything to the power of 0? It's just a 1. Maybe that's what Waddell is talking about, that this just becomes a 1. That's right. This just becomes a 1. Do you see this negative 7? That's going to shoot this a to the bottom. And so we'll have b to the 6th over a to the 7th would be our correct answer for that one. Did you get a pass? Do we have questions on any of those? Okay. We're probably not going to get through everything. Bless you. Now we're going to divide if they have coefficients. That means they have a number in front. Well, if I'm dividing with coefficients, we just have to actually divide the numbers and then divide anything that has a like term on it. Okay? So what we're going to do is we're going to do 24 divided by 8. Take a second and go ahead and do that. Here's Ms. Pabian. Good morning. Yeah. Okay. I need to go to the front office and pick something up. Okay. What's 24 divided by 8? 3. And then we have the c portion. So we're going to have c to the 10 minus 3, which is going to be 3c to the 7th. We're just going to do one more together because we're kind of running out of time. I'd like to get to the backside where you have a lot more complicated stuff. Does anyone see one up there that they want to try together? Which one?
14.
Okay. All right, we're going to do 14 apparently. All right, so we're going to do 36 divided by 4. What happens if we do negative 36 divided by 4? Yeah.
Negative 9k to the second
Ooh,
power.
perfect. It'd be negative 9. And then Dylan went one step further. He realized that, oh, we're going to do 6 minus 4. And what's 6 minus 4? 2. So it's negative 9k squared. I'm going to give us the answer for the other ones. 10 divided by 2 is 5. 3 minus 4 is a negative 1. We can't have a negative 1, so we're going to have 5 over x to the first, or just x if you'd like it. Our last one, we'd have 20 divided by negative 5. 20 divided by negative 5 is a negative 4. Then we're going to have a to the negative 12 minus 4. Those are two negatives, so it goes further negative. So we'll have negative 16. When I flip this fraction, we're going to have a negative 4 on top, and the a has to go to the bottom and be a to the 16th. All right, get those down so they're in your notes. At least you can look at them. Okay. Oh, love that. Love that. Putting extra notes. That's why we have lots of space on this side. We can put our notes on how to do that. Love it. Love it so much. Okay, we'll talk a little bit about simplifying fractions because these don't go in evenly. But this is more or less just practicing simplifying fractions. So 3 divided by 6. 3 divided by 6 is definitely not simplified. What can I simplify 3 over 6 to?
1/2.
It is... Are we staying? No, don't just shout out answers that Campbell gave us. Yes.
1/2.
It is 1/2. It is 100% 1/2. We have to stop and think about answers and not just shout things out. It is 1/2. 3 divided by 6 is 1/2, and you could plug in your calculator. Most of our calculators should be able to simplify it for us. If we don't have a calculator, we should realize that 3 goes into 3 once, and 3 goes into 6 twice. So that's going to be 1/2. Nope, I didn't want any green. And then we'll have h to the 4 minus 1. Well, we should write this one down. 4 minus a negative 1. Because we do subtract what's on bottom. What happens when I subtract a negative? What happens when I subtract a negative? What happens when I subtract a negative?
Positive.
I would like everyone to say that. What happens when you subtract a negative? When you subtract a negative, it becomes a positive. We are actually adding one. So it's 4 plus 1, which is 5. So we have 1/2 times h to the 5th. Or we can write this as h to the 5th over 2. Both of those work. Because when you multiply fractions, you multiply straight across. This is really h to the 5th over 1, so that h to the 5th can go to the top. Abby.
On the other ones, like 13, would you have to put a multiplication sign?
On number 13? let's see here. 13, we had to put a multiplication sign. You would not have to. If you wanted to, you could. There's nothing wrong with multiplication signs. If you put two things together, it's implied that it's being multiplied. But if you want to make sure the reader for sure knows it's a multiplication, you can put the multiplication symbol there. Just like on this one, I put a multiplication symbol there. I did that so we didn't think the h to the fifth went like to the bottom or something like that. But it wasn't necessary. We could just have a 1/2 h to the fifth. We're going to kind of diagonally work our way down so we can get to the more complicated stuff. Okay, so let's do number 20 together. I would like everyone to take a second and figure out what 8 divided by 20 is. And no one shouts out an answer. No one shouts out an answer. We are just figuring out what 8 divided by 20 is, and I'm going to call on someone random to give me what that equals. And then I'm going to call on someone random to give me the W part. So you might want to finish this one. Everyone is responsible for finishing this one. So I'm going to call on someone random to give me the 8 divided by 20 portion. And I'm going to call on someone to give me this portion. Simplify 2.
Help.
Do you need help?
I'll help it.
Okay, what do you got?
2/5.
2/5 is correct. So we're going to have this as W times W to the negative 11. Now we're not allowed to have negative 11. So that W is going to go to the bottom. Right, Campbell? Mm-hmm. So our end answer should be 2 over 5 to the W to the 11, because that negative in an exponent shoves it to the bottom of that fraction. We're going to diagonally work our way down to number 21. I'll circle the 3 things that you need to have done. I need to know what negative 28 divided by 4 is. I'll call on someone to do that. Someone's going to tell me what happens when I have x to the negative 4th minus a negative 4. And then someone's going to tell me what happens when we do our y to the 5th divided by y squared. So I have 3 possible things you get picked on. Either you're going to give me what negative 28 divided by 4 is. You're going to tell me what x to the negative 4th minus, or divided by x to the negative 4th. And then you're going to give me what y to the 5th over y squared is. So we should probably have this whole thing. Oh, you know what, Mr. Pabian? That is x to the negative 4th divided by x to the negative 4th. That should just be 1. Anytime they match up, they're just going to be 1. And Kyra, maybe that'll make that easier on that stuff. That if they match up on top and bottom, they have to be 1. So if your work doesn't support it, we got to go back and check it. In fact, that showed up before, right? Hang on one second. What's c to the 4th divided by c to the 4th? Can we all look up here? What's c to the 4th divided by c to the 4th? Don't say 0. 1. That should have been 1. And if you look at it, it did turn into 1. It's much easier if you just realize it than have to do the math. That we can just go, okay, that just turns into 1. All right, let's look at these more complicated ones. What do we got? These. We're not going to finish all of these. Let's just stick to the left-hand side. We'll do 1 together, and then you're going to be in charge of 25, 27, and 29. All right. The important thing about this is you're going to have to use PEMDAS. PEMDAS says we do parentheses first. Well, in a division, your parentheses are on the top and bottom. You must simplify the top and simplify the bottom before you actually do the division. Campbell, can we sit up like a normal human being? Okay. So we are going to simplify the top first. That has to be the first thing we do. Well, to simplify the top, that's multiplication. What's 4 times 3?
12.
12. Can we all pay attention? Some of us aren't working with us. 4 times 3 is 12.
12x to the 9.
And it'll be 12x to the 9th. Because we did our 2 plus 7. Because of his multiplication, we add. Then it's over 6 to the x to the 6. Excuse me. What's 12 divided by 6? Dylan. 2.
X to the 3rd power.
Okay. So we have 2 here. Do you agree with Dylan? Dylan finished this off, and he went ahead and said, okay, this is going to turn x cubed. Can we check Dylan's math? Does that work out? Can someone explain to me how Dylan got the 3? Yeah. He did the 9 minus 6. So he did the 9 minus 6, so I 100% agree with that one. Actually, let's go ahead and just do... Let's see, I just want to check out which ones I want to do. Yeah, let's go ahead and go left-hand side all the way down to 29. Left-hand side all the way down to 29. I am actually going to put the answers up. Don't just copy them. Try your best at them and see if you come up with the correct answer. I'm going to take a picture of my work. You can actually put down the other answers as well that we have missing. But we are just responsible for 23, 25, 27, and 29. If you want to try the other ones, you can. We're responsible for these. You can check your answers by looking up.
How do I do it when there's different variables?
When there's different variables, you line up the variables that you can do it with. So you have to simplify the top first. We have to do our 10 times 8, which is going to give me 80. Okay?
But I thought you put it variable base.
Well, the variable bases are the same. There's 2 C's. There's 2...
No, it's C and D.
Yeah, we'll do the C portion, then we'll do the D portion. Just like we did up here on 21. We lined up our X's and we lined up our Y's. Yep, so you're just going to line up your variables. So if you look here, notice how I lined up my variables. I put everything in order so I can line up and see what they look like. Can we work, ladies? I'd like to see that you can do this stuff, okay? Let's see. Remember, if we're not working, we're not following directions. Oh, it's not? Okay, so you have negative 9. A to the, not 11 though, because we subtract when they're divided. So we should have 8 minus 3, which would give us 5. Then we add, yep. And then we get our 7. And we should have 7 here, right? Yep, we got our 7 right here. Remember, you don't have to do, we're just working on the left-hand side, or the want to. If you want to do all of them, awesome. It's good practice. These are all basically the difficult ones. These are the difficult ones, right? These are the ones that only show up a couple times on a test. If you look at your homework, it starts out a little easier than that.
But none of you the ones on the left-hand side?
Just the left-hand side.
Oh.
If you want to do the other ones, you can.
I didn't know the three.
If you want to just do the left-hand side on your own and then copy the other ones down, that's fine. 'Cause you only have 10 minutes. I'd like us to get a good shot of being able to ask questions.